Hello everyone, myself Vikas Kumar and I'm studying in Sri Venkateshwara College of Engineering, third sem. Branch is Information Science and Engineering, subject is Operating Systems, and the topic is Deadlocks. A process requests resources. If the resources are not available at that time, the process enters a waiting state. Sometimes a waiting process is never again able to change the state because of the resource it has requested are held by other waiting processes. This situation is called as deadlock. System model. A system consists of a finite number of resources to be distributed among the number of competing processes. The resources are partitioned into several types of each consisting some number of identical instances. Memory space, CPU cycle, files and input-output devices are example of resource types. A processor must request a resource before using it and must release the resource after using it. A process may request as many as resources as it requires carrying out its designated task. The number of resources requested may not be exceed the total number of resources available in the system. Under the normal mode of operation, a process may utilize the resources in the only following sequence. First, the process requests the resources. If the request cannot be granted immediately, then the request process may wait until it can acquire the resource. Second, use. The process can operate on the resources. Third, release. The process releases the resources. A set of processes is in a deadlock state when every process in the set is waiting for an event that can be caused only by another process in the set. The events with which we are mainly concerned here are a resource acquisition and release. The sources may either be physical resources or logical resources. Deadlock characterization. Necessary conditions. A deadlock situation can arise if the following four conditions hold simultaneously in a system. First, mutual exclusion. At least one resource must be held in a non-shareable mode. That is, only one processor at a time can use the resource. If another process requests the resource, the requesting processor must be delayed until the resource has been released. Second, hold and wait. A process must be holding at least one resource and waiting to acquire additional resource that currently being held by other processes. No preemption. Resources cannot be preempted. That is, a resource cannot be released only voluntarily by the process holding after the process has completed its task. Circular wait. A set of POI and PN of a waiting processor must exist such that PO is waiting for a resource held by P1 and P1 is waiting for a resource held by P2 and so on. Pn minus 1 is waiting for the resource held by Pn and Pn is waiting for the resource held by Po. Methods for handling deadlock. The deadlock problem can be handled in one of three ways, using a protocol to avoid deadlock, ensuring that the system will never enter a deadlock state, allow the system to enter a deadlock state, detect it and recover. Third, ignore the problems altogether and pretend that deadlock never occurred in the system. Deadlock prevention provides a set of methods for ensuring that at least one of the necessary conditions cannot be held. These methods prevent deadlocks by constraining how requests for resource can be made. Deadlock avoidance requires the operating system to be given in advance additional information concerning which resource a processor will request and use during its lifetime. With the additional knowledge, it can decide for each request whether or not processors should wait to decide whether the current request can be satisfied or must be delayed. The system must consider the resource currently available, the resources currently allocated to each processor and the future request and release the each processes. If the system does not employ either deadlock or prevention deadlock avoidance algorithm, then the deadlock situation may arise. In this environment, the system can provide an algorithm that examines the state of the system to determine whether a deadlock has occurred and the algorithm to recover from the deadlock. In the absence of algorithm to detect and recover the deadlocks, the system is in deadlock state, yet has no way to recognize what has happened. In this case, the undetected deadlock will result in deterioration of the system performance because resources are held by the processes that cannot run, and because more and more processes they make request for resource will enter a deadlock state. Eventually, the system will stop functioning and will need to be restarted manually. Resource algorithm graph. Deadlocks can be described in terms of directed graph called system resource allocation graph. The graph consists of set of vertices V and the set of edges E. The set of vertices V is partitioned into two different types of nodes, P equals P1, 2 and Pn. The set of consisting of all activity processes in the system R equals R1 R2 to the Rm. The set consisting all the resources types in the system. A directed edge from the processes Pi to resource P type Rj is denoted by Pi at Rj. It significantly the processor's Pi has requested an instance of resources type Rj and is currently waiting for that resource. A directed edge from a resource type Rj to processor Pi is denoted by Rj Pi. It signifies that instance of resource type Rj has been allocated to Pi. A directed edge Pi to Rj is called as request edge, and the directed edge Rj to Pi is called as assistance assignment edge. Thank you.